And guys, we're paying attention.
Good day, guys. Welcome to one of the fantastic programs that have been organized by the TDA, Ask Your Teacher, where we'll be going live with your teachers of the various subjects that you are doing, and you have the privilege to interact with them through questions and asking anything so that you are prepared for your exams. We welcome you. Our lesson today is going to be motion, and this is IGCSE Physics 0625, covering both the core and the extended options. We go into it. We have selected a few objectives from the IGCSE 0625 Physics syllabus, motion, where you are required to define key terms which you find under motion. You are also supposed to calculate the average speed, acceleration, distance, and using simple equations of motion. We are also going to be able to plot or sketch speed time graphs, distance time graphs, and interpret them. The terms that we need to know include distance, displacement, average speed, velocity, acceleration, deceleration, retardation. So you need to go through these terms as you prepare for your lesson, as you look at them. Distance, the length between 2 points measured in meters. Displacement, same as distance, but this one has got direction. And if you know a quantity has got direction, we are saying this is a vector quantity. Average speed, you're looking at the total distance covered divided by the time. Velocity, same like speed, only that velocity has got the direction quoted or mentioned. Acceleration, the rate of change of velocity. And when we say rate of change in physics, we are saying per unit time, as you see when we do the calculations. Deceleration, this is when speed is decreasing, which is also negative acceleration, which can also be called retardation. So you see that deceleration, retardation, and negative acceleration, they are all terms which are describing one thing. Equations of motion. There are a number of equations that we have to know, which will be required to use in the exam, as shown. Average speed, which is equal to distance divided by the time taken. And your units are meters per second or kilometers per hour. So it depends with what you are given in the question, and you use the correct units for that. We've got velocity given there as distance moved in a stated direction divided by the time. It will have the same units as average speed or speed, meters per second or kilometers per hour, depending on your calculation. You have acceleration, which is change of velocity divided by the time taken for that change. And the units are meters per second squared. With now these formulas represented in symbol form, where you are saying V equals U plus AT, and you need to know what is V, what is U, what is A and T. These quantities, you are going to get them from your question. Like V will represent the final speed or final velocity. U is the initial speed or initial velocity. A, small letter A, here take note, small letter A for acceleration. And T, your time. Then we have S is equal to U plus V over 2 times T. Your S here is representing the distance covered, the height, the length. So it depends with the question. It can be representing all those quantities: distance, height, depth, or length. Then we've got another formula there for distance, which is S equals to UT plus half AT squared, which is your U representing your initial multiplied by your time, then half AT squared. The final one is V squared minus U squared plus 2AS. All those are equations of motion which will be required to use in your exams. We look at motion graphs. We've got two types of motion graphs that we are supposed to do under the IGCSE 0625 syllabus: speed time graph and the distance time graph. Speed time graph, also called the velocity time graph. And we've got one shown there as a speed time graph or velocity time graph. Now, you look at that, at this graph, the most important question which comes, which is the most common question, is for you to describe the motion of the object, where you are required to describe the motion of the object. The issue is to break down the word motion, and we are saying when you are describing motion in physics, you are describing the speed or the acceleration, and you are going to use your descriptive words like increasing, decreasing, constant or uniform, or steady. So you just indicate the increasing speed, decreasing speed, constant speed. That is how we answer this question, which is usually the most common question. They describe the motion of the object. The gradient or the slope gives us the acceleration, and you need to calculate this gradient using change in speed over change in time. From your mathematics, you'll be saying change in y over change in x. Same thing here, change in speed or change over change in time. A line with a constant slope or a constant gradient gives you uniform acceleration or uniform or steady speed. Then a curved line represents changing acceleration. It can curve upwards, it can curve downwards, as we see later on. And when it is curving, we are saying the acceleration is changing. It's either increasing or decreasing. The second most important question that you'll be required to do or to attempt is to calculate the distance moved by the object. And we are saying for this one, the distance moved by the object is the area under the graph. So you have to demarcate a certain area under the graph. And this area can be a triangle, it can be a rectangle, a square, or it can be the whole shape in the form of a trapezium. So you are going back to your shapes and you are looking at the basic formulas to get the area of a shape. Area of a triangle, we know half base times height. Area of a rectangle and a square, width times the length. So you need to demarcate the area that you are dealing with and see what shape is it. Is it a base, a triangle? Is it a rectangle or a square, as shown on the diagram there? When you get this area, we are saying it's going to represent the distance covered by the object. So you are not going to record your units as meter squared or centimeter squared. You are going to use the units of distance, which are meters or kilometers, depending on the question. We've got a question for you there to look at, where you are required to calculate the distance covered by the object from P to Q, starting at 20 meters per second, going to 40 meters per second. You see that we divide the area into two parts, the shape of that graph into two parts. We've got a rectangle shape and the upper part, which is a triangle. So you are going to calculate the area of a rectangle, or PRS, which is length times width, and the area of a triangle, which is half base times height. Your base there is 5. Your height is 20. For this height, you have to take particular caution there. You are subtracting 20 subtracted from 40. So that you don't use the full height as 40, but we are saying it's 40 minus 20, which gives you 20. Compute that, you are going to get the area of the rectangle is 100 meters, the area of the triangle is 50. Then you add them together, you get 150 meters is the distance covered by the object between P and Q, or in 5 seconds. You have to note there that the units can vary depending on the question, especially extended option. But we are saying you have to make sure that when you do this question, the units for velocity and the units for time should be tallying there. Meters per second for velocity should go together with seconds. Then kilometers per hour, you need to change them again to meters per second. A very common question in the extended option. Non-uniform motion. We've been describing motion which is in a straight line and the velocity was constant, the direction being the same. We've got a non-uniform motion where you are either increasing or decreasing the acceleration. You are going to see this on a speed time graph, and it's shown by the graph being curved upwards or downwards as shown. If a graph is curving upwards, we are saying acceleration is changing, acceleration is increasing. And you'll be required to do some calculations again of that acceleration. Remember, we have already said that the gradient of a speed time graph gives us the acceleration. The gradient of a speed time graph gives us the acceleration. Then you have to find the acceleration now at a point. And to find acceleration at a point, you are required to draw a tangent. And you go back into mathematics. A tangent is a line which is touching a curve at one point, or touching your graph there at one point, shown there either as T1 or T2. Then you look for 2 points which are on the line, which you use to calculate your gradient. And as a tip there, exam tip there, one of the points is already given as the one at T1. But you can as well pick any other 2 points which you want, and you use them to calculate your gradient. Remember how to calculate your gradient. You are following the triangle method. Change in y over change in x. Then you will get your gradient. If you follow through the diagram or the graph that we have, you will see that at T1, there's a low gradient. It's less steeper. The slope is not very high. But at T2, the gradient is increased. And we are saying acceleration is increasing. So when we describe the motion, we are saying this is showing increasing acceleration. Remember, when we said we are describe a motion, we use descriptive words: increasing, decreasing, constant, and we'll be referring to the speed or the acceleration. So speed is increasing, and we also note acceleration is increasing at T1 and T2. We look at decreasing acceleration. For decreasing acceleration, our graph or our curve is going to slope downwards, as shown on the graph there. And we are recording this as a decreasing acceleration. You also be required to calculate the acceleration following the same procedure that we have done for increasing acceleration. You draw a tangent. You are going to draw a tangent touching that curve at one particular point, which is T1, or at T2 as shown there. Then you calculate your gradient following change in y over change in x. You will see that at T1, the line or the gradient is steeper. The slope there is steep. So we are saying there is a decreasing acceleration, high decreasing acceleration there. Then we go to T2, where the gradient is low, a low decreasing acceleration there, meaning our object is slowing down and it can eventually move at constant speed or even come to a halt or stop. So these are the typical questions, typical objectives that you need to cover under the topic motion in your IGCSE 0625 syllabus, both the extended and the core option. At the end there, we have got IGC past papers revision questions, which you can attempt. And you see that most of them is question 1. Motion is going to be the first question you will get in your exam. and you need to have the confidence to go through it and attempt it, since it is question number 1. So that is our physics section. Motion. Thank you. We take a break.
Well, last year when I was in standard 6, the school introduced a club called the Media Club. I decided to join it, then I got accepted. And that's how we came to make the future of this land. Like my grand queen mother would say,
be fearless. Be like your father.
Well, in the film, I learned a lot about acting and types of shots that the camera takes. And my favorite character in the movie is Mati, the place where my father was born. A place his forefathers lived and passed on to the afterlife. Now it's just a place. I was surprised to see myself in the newspaper.
This is the first time. How did your parents feel about that?
My parents felt proud and happy for me.
I'm a teacher at the Dow Academy. Currently, I'm teaching physical education.
Place of my giant ancestors.
Watching myself on the big screen, wow, that was mind-blowing. I would watch some movies on the big screen, but now to see myself there, it's like looking in the mirror and wondering who else is watching you. That is amazing. My favorite part was when I had to cup in with the magic stick and it sounded like an earthquake, like a lightning bolt.
He brought peace amongst our people and all tribes.
And then my first lines, imagine a war caused by peace. That was nice.
Imagine a war caused by peace.
But you always said peace was the end of war, not the cause of another.
A hunt to kill.
You must behave so.
Even so, my queen, I was also once a child. I also did childish things. I had to grow into the warrior king that I am today.
smart. You are a princess and you should act like one. Orara Kadiwai, I'm soon to be the queen. And you girls must start acting like princesses. Dress like princesses and let the boys be the boys with their warrior-like behavior. My team, let's go.
Young princess, I understand you've been running around playing warrior again. Is that correct?
I'm sorry, grandmother. I just wanted to play and learn how to.
Welcome back. I hope you enjoyed the first session. And let's remember to maintain our COVID protocols. Mask up, sanitize, maintain the social distance. You allow me to remove my mask for this broadcast, but always maintain your distance and sanitize. Welcome back to the second session where we are going into our question and answer session. We are opening the platform to any questions that you'd want at the topic at hand, motion, IGCSE physics. Just a recap, whilst we are waiting for the questions to come through, know your definition of terms. Part A of the question will be as simple as define acceleration, a mark or 2 marks. So we are saying, get to know your definitions of terms. Then know your graphs, your motion graphs, in particular, the one we are looking at today, the speed time graph, describing the motion there. And when you describe the motion, you are breaking down the word motion into either speed or acceleration. And you are saying, is the speed increasing? Is the speed decreasing? Or is it constant or uniform? Then the third one, which will come there, is for you to do the calculations. Calculating average speed, total distance divided by the total time. Or you are doing your acceleration, which is the gradient of that line or the slope. Change in speed over change in time. So that was a recap which we need to know on this. We are in the question and answer session.
Yeah, I have a question here.
Yes.
It goes, what is the unit of acceleration? What is the unit of acceleration?
Okay, a wonderful question. Very common in multiple choice. I think we've indicated there in our lesson, the units of acceleration are meters per second squared. What are we saying when we are saying meters per second squared? It is going to the definition of acceleration, change of velocity or change of speed per unit time. So we've got the units of speed at the same time being divided by the units of time. That is why we are saying our units of acceleration are meters per second squared. At what rate are we increasing or decreasing our speed? Thank you very much for a nice question, common in the multiple choice section. It's our Q&A. We are waiting for questions to come through.
How does mass affect?
Can you come to the mic?
How does mass? How does mass affect acceleration?
How does mass affect acceleration? Very good question. Forces and motion. If you remember, we've got forces and motion and Newton's second law of motion, F is equal to ma. So what can we say from that? If an object is a higher mass, it takes time to accelerate. It takes time to accelerate, and we can explain that in terms of inertia, the resistance of a body to change its position or change its velocity. So at the end of the day, what is the relationship between mass and acceleration there? If an object is a higher mass, it takes time to accelerate. The acceleration will be low. We are waiting for questions in the Q&A, question and answer session, where we are welcoming questions on our topic, motion.
I have a question about demarcating the graph area under the graph. How do we demarcate? Is there any criteria to demarcate area under the graph?
Wonderful. Thank you for that question. To demarcate the area under the graph, if you can go to the slide where we've got our graph, you can be guided by the question itself. Usually the question will read, calculate the distance covered in the first 5 seconds. So you are going to where we've got 5 seconds, you mark now, that's your demarcation area. If we look at the slide where we've got the graph and we are calculating the distance, or it can be calculated the distance covered in the first 2 seconds. Let's start with that one. So you are going to where your 2 seconds is on the graph, then you can mark that. Maybe I can illustrate this on the board. Let me illustrate the demarcation there. We've got our graph, which we are using with our time in meters, our velocity in meters per second, our time. And we are saying you are going to follow the question. It's going to say, what is the distance covered in the first 4 seconds? So you are going to 4 on your x-axis. You draw a line coming downwards. So we are dealing with this area under this particular graph. So usually you are guided either with the time or they can use letters between A, B. So let's say our speed here is 10. Then this one we use 15. So we are going to calculate this area from 0 to 4 and your other speed here being 10. And you create a shape which can be a trapezium, or you can divide it again and create 2 shapes, a triangle and a square or a rectangle. That is how we demarcate, using time, or you'll be given the section. Thank you.
Another question.
Yes.
It goes, a girl walks 75 meters in 25 seconds. What is her walking speed?
She walks what?
75 meters in 25 seconds. What is her walking speed?
Okay, thank you very much for the question. If you are following through the question, we see that we are already given the distance and we are given the time. And if you go back to our formulas that we have given out, equations of motion, you are going to use the total distance divided by the total time taken. So our total distance given in this case is 75 divided by the time that we are given there is 25 seconds. You divide that and you get your answer there is 3 meters per second. Thank you very much. A very nice question. It's our Q&A. We are waiting for questions on the topic motion from the IGCSE 0625.
Another one.
Yes.
How do we calculate the distance covered in a speed time graph with a curved line? How do we calculate distance covered in a speed time graph with a curved line?
A very good question, which we are still going to attempt and use what we've talked about, the area under the graph. So you are going to try and demarcate your graph into a shape that you are familiar with, which can be a triangle, a trapezium, or a square, and you apply the same principle of area under the graph. Although it can come with some estimations in some areas, especially where it is curved. But usually for IGCSE, we work with uniform motion when you are calculating this distance. You are usually involving straight lines, but it can be a question which you can get and use the same principle of area under the graph. Thank you very much. A very good question.
Another question. How do you know which equation of motion to use?
Okay, Very good question. Which one do I use? Because there are many questions of motion. We just gave you a few here. I think the first one is, what are you calculating? What are you calculating? Both the question has to be clear on what are you calculating. If you are calculating distance, then you are following equations of motion which make use of distance. But we know once you have one equation, you can rearrange. Mathematics, you're talking of change of subject of the formula. You can do that to get any other quantity in the question. So you can be starting with an equation for speed, but I'm calculating distance. It's very possible. I'm doing rearranging or subject of the formula. So the question is usually very clear and very precise there on what you use. For distance, like what you have said there, distance equals speed multiplied by time. You can have the others which you have mentioned. Distance S equals to UT plus half AT squared. We can use that one. So we can use any formula as long as we are able to rearrange. Thank you very much for the question. We are in the Q&A.
Another one goes, sometimes they bring questions such as calculate the minimum and maximum speed. How do you attempt that question?
Thank you very much. A very good question, especially in the extended option. Right. Maximum speed on our graph is when our gradient is very steep or the highest. So we are going to use, especially on a distance time graph, that's when we get this question. Remember, on a distance time graph, the gradient of the graph gives us the speed, and we didn't talk much on that today, to be for another lesson. So we are saying maximum speed is actually where the graph is the highest gradient, and we are saying is distance divided by time. Your distance is also your change in y, and your time is your change in x. It's a very good question. Thank you for that one.
Any question from the floor? No. Let me go back. What quantity is the rate of change of velocity? What quantity is the rate of change of velocity?
Oh, thank you. A very interesting question there. Rate of change of velocity, you can see that this is acceleration. So that is the definition for acceleration, rate of change of velocity. So you're just playing around with your words, and you are using that also as your definition for acceleration, rate of change of velocity. And in physics, when we say rate of change of, we are saying dividing by your time, is per unit time. So we are saying your speed that we have divided by the time. So that question is talking about acceleration. Thank you very much. A very interesting question. We are in the Q&A questions based on our topic, motion. Okay, we are going for a short break. Remember to mask up, sanitize, maintain your distance. Thank you very much.
Hi, welcome to the girls' boarding facility. As you can see, we have a lovely pool so our girls can spend some time out and exercise and relax. Beautiful courtyard where everybody can sit and enjoy some meals. But obviously, what you're here to see are the bedrooms. So why don't we go inside and check those out? Lots of lovely places for our girls to sit, do their homework, read, and hang out. We have another additional indoor dining room where our students can have their meals, their breakfast, or again, do some more homework. And through here, we have majority of the bedrooms, so let's go take a look. So here's one of the girls' bedrooms. As you can see, we can host up to 4 girls in this one room. Every room has their own air con. Again, for those hot nights. We have over here a TV in every single room and a mini fridge, so they can store some of their snacks or have a little bit of downtime. and a little space for them to do their homework. And similar to the boys' boarding facility, every room has its own bathroom as well, so they have their privacy. Welcome to our boys' boarding facility. Why don't you come in so I can show you around? Every room has a little ensuite kitchen that comes with a fridge and obviously a TV for entertainment. Why don't you come this way? As you can see, it is a very spacious room. We can have 4 boys living comfortably. Everyone has a bed. Every room comes with some air con for those very warm nights. And obviously a little study area if they want to do their homework. Additionally, all rooms have their own ensuite bathroom, so they each have their privacy. I wouldn't mind living here myself. Well, that concludes our tour. Thank you so much for checking out our boarding facilities. We hope to see your child join the TDA family. So we're here at our reception campus where we have 4 classrooms that can accommodate up to 100 students. Each classroom has a smartboard and a whiteboard. And actually one of them we have converted into our media lab. So our coding class takes their coding classes there twice a week. And also then our lower standards come in for their IT classrooms. So let's go check it out. So here we have the media class. As you can see, it's set up to host 20 kids. So let's go check it out. So this is a classroom where we have coding and IT. So one of our tech series programs is Rebuild a Desktop. So as you can see, they've taken it apart and they get to learn about the components, how a desktop works, troubleshoot it, and then they get to put it back together. And fun fact, in the next few weeks here, we're going to have the second installment of the Sword and Maturity. So check out some of the scenes. This room might look familiar to you in a couple of weeks.
You're listening to
Welcome back. Thank you very much for the question and answer session. Very good questions. Welcome back to the TDA Teleradio Ask Your Teacher, where you are meeting your teachers for the various subjects that you are doing, and you have the privilege to ask them some questions. And we also help you to go through some of the materials, bring them to your level so that you are very confident in your exams. Thank you very much. Today, our topic was the first topic, motion, in the IGCSE 0625 syllabus, both covering the extended and the core options, 41, 42, 43, or 31, 32, 33. Motion, we are saying you'll be required to do definition of terms, and the common terms which you'll be required to define there include acceleration, velocity, deceleration, distance, speed. The common terms that we use: acceleration, the rate of change of velocity or change of velocity per unit time. And as you do your definition, you can see that you are also able to get the formula on how to calculate these quantities. So our first part of the question will be on the definition of terms, and look at that. You also be required to do some calculations using simple equations of motion for average speed, which is the total distance covered divided by the total time taken, units coming in meters per second or kilometers per hour, depending on the question. You also be required to calculate your velocity using your equation v equals to u plus at. And this equation is this, we are getting it from the equation for acceleration, where we are saying a equals to v minus u over t. Like we have said in the lesson, you can rearrange or you can make the subject of the formula to calculate any of these quantities. You also be required to look at your motion graphs, the speed time graph or the velocity time graph. And the common question which comes below this graph will be to describe the motion of the object as shown on the graph. And we are saying the issue is for you to break down the word motion and use speed or acceleration. And you are going to describe using increasing acceleration, increasing speed, decreasing acceleration, or decreasing speed. Or you can also say uniform, which is constant and not changing. So it's all about your descriptive words there that you are using. You also be required to calculate the distance moved by the object. And we are saying this is the area under the graph, and you can write that as a formula, area under the graph. It will be credited a mark. Then you go on to calculate the area of the specific shape that you are getting, which can be a triangle, half base times height, a rectangle, we know width times length, or you can use the compound formula for a trapezium, half a plus b multiplying the height. So that is area under the graph, which we use to calculate the distance covered. We have non-uniform motion where the graph is curving upwards or downwards. And we said when it's curving upwards, it's increasing acceleration, and you'll be required to make use of a tangent, which you draw at a point, and you calculate your gradient using points which are on the line. You can also have decreasing motion, which is curving downwards, calculated using a tangent drawn to the curve. So that was our lesson on motion, and we're doing the recap. Thank you very much for tuning in to the lesson for the question and answers. We would like to thank the crew behind the scenes in the studio here. And we also would like to thank the TDA management for the fantastic opportunity of bringing your teachers to you in the Ask Your Teacher session. Join us tomorrow for the same session, same time, 1:15 to 2:00, where we feature in another subject from another teacher. Be ready with your questions. They'll be helping you. Thank you very much. Remember to stay safe, mask up, sanitize. Thank you.